Hi, I'm Simon from TU Munich, and I'm very glad to speak on behalf of my co-authors, Baris, Nikita, and Daniel, to present our CVPR paper, Flattening the Parent Bias, Hierarchical Semantic Segmentation in the Poincaré ball. Hierarchy is a natural representation for semantic taxonomies. Given an image on the left, our task is to predict for each pixel a tree-based label hierarchy. For instance, by using the label tree on the right, labeling such pixel as a human and more precisely as a person, or such pixel as a vehicle and also as a car. To summarize our contributions, we find that recent popular hierarchical approach that models the parent logits as signals in the training process is non-semantically meaningful. In contrast, flat classifiers are strong baseline for this task, but may be limited by a parent bias in Euclidean space. We show that operating in hyperbolic space allows for mitigating this bias. In particular, we demonstrate strong generalization of the Poincaré ball model in terms of accuracy and calibration, especially on parent categories. First, let us revise some recent formulation that models the hierarchical task as a supervised multi-label classification problem. This formulation simultaneously predicts child and parent nodes. Surprisingly, the parent signals in the training process increase segmentation accuracy on the child nodes themselves, at least according to the original work. The reason is unclear. To demonstrate the lack of semantic meaningfulness, we train the model with non-semantic taxonomies. For instance, in the tree B, the node person is not defined as a child of vehicle. We find that the accuracy with non-semantic tree is not different from the accuracy with semantic taxonomies, tree A. We conclude that this hierarchical approach is unrelated to semantic taxonomies. That contradicts the main assumption of hierarchical training. A contrario, traditional flat classifiers only predict child class posteriors. Given child classes in orange on the figure, we simply infer the probabilities of the parent, in pink, by summing the probabilities of the child class posteriors, as we operate with a closed-world taxonomy. Flat classifiers represent a good baseline for hierarchical segmentation task. However, we reveal that Euclidean networks may suffer from the parent bias. Let us explain why. On the figure, class B is closer to the hyperplane of class C than class A. The spatial proximity between two classes will encourage the grouping of one class over the other when considering parent-level categories. That leads to suboptimal parent-level accuracy. In contrast, let us analyze segmentation in the Poincaré ball. The distance between A and B and the gyroplane is experimentally more uniform. That mitigates the Euclidean parent bias and leads to stronger generalization of the parent-level prediction. An explanation can be found with a simple analysis of the respective distances. In particular, hyperbolic distance, in red on the graph, is strictly concave with respect to Euclidean distance, in blue. It follows that a change in the Euclidean distance between two embeddings will be more mitigated in the hyperbolic space than in the Euclidean one. We conclude that hyperbolic representation flattens the parent bias. Experimentally, we plot the difference of accuracy with a hierarchical approach, for instance with OCRNet. It clearly appears that flat classifiers are much more generalizable than the hierarchical approach, and in particular in the hyperbolic space, the red bars on the figure. The gain in accuracy is notable for all 6 datasets, whatever the domain shift. Similarly, we plot the difference in the calibration error. The hyperbolic representation is much better calibrated than both the hierarchical approach and the Euclidean model, whatever the domain shift. To conclude, we insist on the fact that existing hierarchical models do not generalize well. In contrast, flat classifiers are very strong baselines. Whereas Euclidean representation may suffer from the parent bias, the Poincaré ball allows for mitigating this bias and is more robust to domain shifts, in terms of both segmentation accuracy and calibration. Thanks for your attention and feel free to visit our project page with the QR code.